the CO2 emission reduced, and then the energy consumption also reduced. So prediction of energy now has been affected as a result of this. So now, if prediction has been affected, it's also an opportunity, like I said earlier, for us to look towards the green energy. So during the lockdown, this is just the data for us to take a look at. You can go on. Okay, this is one of the predictions. Like I told you, look at the gap. Avoided emissions. So these avoided emissions should be where we should be looking at. If we can avoid this emission during lockdown, in fact, it may not be a case here, but it's a case elsewhere, such that when you go to a particular place, they will write boldly, please ensure you stop your engine from idling. So idling of engine is also a source. So when lockdown was in place, that reduced the avoidable emissions. So can we go on? So the concluding remarks basically is that policymakers should be taking a look at the direction of green energy, and research showed that 40% of the papers argue that crisis will curtail those that are enthusiastic about climate change, which means this crisis is also a good one, because those that are interested about climate change will begin to think of, okay, if it is possible for us to reduce the CO2 emission during this period, then it is also possible for us to have the effect of this energy on climate change. And then 35% argue that the cyclical slowdown will pull forward the peak in fossil fuel demand. It will create space for policymakers in energy importing countries to remove fossil fuel subsidies and tax externalities. Externalities are the effects felt. For instance, if you are operating on generating sets, the effects of CO2 you are emitting and the effect of the noise are the externalities felt by those that are not using it. So the carbon buy now, those that are the passionate about carbon purchase now are saying, if you are not emitting carbon, then you should be able to be given some subsidy for that purpose. And if you are emitting more, you should be taxed more. Now, this will give us a direction towards that. And why should you be taxed more? Because when you emit more, of course, we know you are affecting the climate change, and then you are also affecting the ozone layer. So a lot of issues, of course, the environmental friendliness is not so a challenge. So this will give us a direction that, look, if you really want to do carbon buying truly, and you want to tax those that are emitting that, like the genset we are using, then you may have a justification for taking such decision if this much gap has been created during COVID-19. So this should act as a midwife for energy transition policy and green innovations. Thank you.
Thank you for the presentation. Last but not the least, it may not be on the program sheet, it's just an omission. So, and it may not be in total trajectory with what we've been listening to, but it's also what we should listen to. So may I please invite to the mic Suleiman Awal Akinwumi. He'll be talking to us on consequences of tropical geometry on Starlight classical full transformation semi-groups. Suleiman Awal Akinwumi, please. You have 10 minutes, and your time starts now.
Good afternoon. So I will be discussing the consequences of tropical on Starlight transformation semi-group. I'm by name Suleiman Awal Akinwumi. So I'm a PhD student. So on the fact that graph is widely used on transformation semi-group, so we are trying to consider how we can transform our transformation semi-group in a graphical illustration, and that is the major focus of the research. And what do we say when we say transformation is said to be star-like? It is when we consider the domain and image of a transformation consequentially, diagonally to one another, and looking at the occurrence of the image. So we can move to the next slide. Next slide. So, next slide, okay. On equation 1, On equation 1, we give an equation on what we mean by star-like transformation. And so we want to look at converting a transformation into a classical polynomial that we all know, and our transformation contains a natural number, which is a subset of the real number. So, and we have it, sorry, back. So let's quickly go back. Okay. So in equation 1, we have that as the equation for our Starlight transformation. So when we consider the image and the domain respectively, which is going to be less than the inequality of the image and the domain. So for all elements of natural number, which is member of the domain, and ki, which is member of the image. Next. So next. So, and we want to consider that a Starlight semigroup is of order n, which our n is of non-negative integers, satisfy some definite axiomatic properties, which contains a positivity, must contain identity, and must have an inverse, and it must be linear, and we have the proof follows. Next. So, and next. So these are just the definition that we use during the course of the proof. So what we mean by tropical root, so we look at tropical multiplicity, is that we consider a tropical curve of our transformation, and we try to look at what is the consequence of it on the transformation. That is why from there we look at the union of the two slopes, whereby the transformation forms a slope, and we take the maximum. So next. So we have the definition of Starlight mapping. Next, let's move on. So this equation 2 is just giving us a typical representation of our transformation. When we have it, consider where W1 to N are the number, a set of the domain, while that of K to Kn are the image element of the image respectively. And we have it transformed to 3. Next. So from equation 3, we have equation 4. Then from there we generated a polynomial in equation 5. Next. So in the result, we consider the general known equation of a line, and from there we have a tropical line in 3 dimensions, which we have in figure 1 this. Next. So majorly, after performing the operations on our transformation semigroup, the multiplicity obtained and the root obtained from the semigroup forms a tropical graph, which we illustrated in the figure seen. Next. Then next. So these are elements of the full transformation semigroup of order 3. That is, considering the equation 1 that has been set, so we see that all these elements are star-like in nature, and they are full respectively. Next. So, and the result obtained in this our research work show the classical features in the applications of transformation semigroup in tropical algebra with some tropical and combinatorial properties. Next. So these are the results that we were obtained and were proved. Next. So if you look at if you look at theorem 1, we say that for any given Starlight transformation of the full Starlight, there exists a real number, which is C, such that we must satisfy the following axioms theorem properties, and which, when we consider 3 transformations, alpha, beta, and omega, which is a member of the full transformation, so we see that, next slide. So when we perform the closure properties, it satisfies, and we look at the inverse element as well, and it is enclosed since our transformation is monoid, that is a semigroup with an identity. Then we look at the inverse respectively, such that if and only if a transformation alpha commuted with transformation beta and give us the identity, and vice versa. Next. So we look at the linear combinations of the transformation, which we consider some element of that, and by considering it where our transformation contains a natural number, there exists omega, such that when we perform an addition operation on the 2 transformation, we have what we have as C. Next. So, and if you consider the domain and image set of our transformation in equation 6, and we perform the classical transformation this way, and these are how we transform our transformation into into classical polynomial, which we considered our m squared plus m to be this, and from there we computed the starlight graph. Next slide. So next, this is how we computed the transformation in the equivalent classical polynomial. So, and we use these polynomials. Next. So from the polynomials, next. So we have the graph plotted respectively, and from the graph we consider the root and the multiplicity, which forms the yellow line, and that multiplicity is that of in blue color, and that of the red is showing the root. So from there we have this, which is graph 1, and we have the graph follows respectively. Next slide. So, and that is how we plotted the graph. From the graph, we observe that though some multiplicity and roots of a classical transformation might be different, but they share similarity in terms of the root, and that is why we try to classify those that are of the same nature. Next. So after we look at those that are of the same nature, then we use them to form a theorem. Next slide. Next. So move to the next. These are just the graphs that we have obtained from the transformation, and taking in each case of the tropical graphs that we have considered. So we consider each of the size ranges from n to whatever value taken, and where our combination n of that root is the number of subset of size un of that, whenever our n is greater or equals to 0, and we observe that that combination equals to 0 if the multiplicity equals greater than n, and from there taking an initial condition which is to be 1 and that is to be 0, then next. So the currents allow us to quickly determine the height 1 and consists just one of the number below that of the first row, and we have it in figure 17. Next slide. So these are the multiplicity orders that was generated from the operation of the tropical polynomial on the transformation full starlight, and we also give an algebraic expression of this that makes sense of all n whenever we consider our multiplicity greater than or equals to 0 using the factorial starlight function defined combinatorially as numbers of weight arranging and descending element. Next. So combinatorially, so we have this equivalently imitating the Pascal triangle, forming a combinatorial form using the multiplicities and the tropical classical polynomial. So where we have it as the order symbolically, as we can see in figure 18. And lastly, next. So we note that it's fairly evidently the number of order list of multiplicity distinct elements from our non-negative m, which starlight identity differs 1, occurring in the multiplicity order of all set of transformation. Next. So, and we have the remark that since our transformation is a bijection and contain an empty map, we have this to be 0 and that of rank to be 0 as well similarly. So, and we have the reference.
Thank you.
Thank you very much.
Please let's appreciate him. Thank you for the presentation. You can please take your seat. So we've listened to the 6 presentations. So it's now time to take questions and comments from the distinguished audience. So if you have, we have just maybe 17 minutes for this session. So let's see how far we can go. If you have questions, comments, let's give us a number. We'll take the round and then we can. Okay, I saw the first hand there. I need someone to please help me with the mic so that we will save time. Just help me take it to them. So I'll give us number, just hold on. Number 1. Hands again. Number 2. Number 3, number 4, number 5. Okay, I'll be this. Oh, number 6, I'll be the 7th. So please just write down the question that is addressed to you. You'll just take the turn. So if only one round we can have, fine. But if you can go the next round, that'll be fine. Let's look at how far we can manage the time. 2 minutes for your question. Don't let us explain more than 2 minutes.
Thank you.
Yeah.
My first question goes to Dr. Rohera Christopher Wakara. In your presentation, you mentioned so many things about women, and there is no point you actually acknowledge the fact that COVID-19 has caused women to ask so much from men. In terms of expectation, where we normally spend 10,000 naira before, now women, we are spending 20,000 naira. And you didn't acknowledge just a statement that all the men, kudos to you for keeping up. So please help us to speak on that. There should be a way to appreciate us for that. So thank you for your presentation. My next comment, kind of suggestion is to Dr. Adebayo Oluwasegun. You make a wonderful presentation, but when it gets to conclusion section, the first conclusion you presented to us is not really a conclusive statement. You make us known that the first conclusion is that you actually there should be a further conclusion, further study on what you've just presented to us. So I'm sharing this with everybody based on peer review skill that if you have studied something, your first conclusion should focus on what you've studied, not telling us that there's need for us to study again. So please take note of that in your presentation. You should focus on your conclusion. So there should be a conclusive statement on what you've just presented to us. So, and then the last presenter, kudos to you, sir. I appreciate you. Thank you very much for that wonderful information. Thank you again. Thank you very much.
Yes, it's just a suggestion for the last presenter. I think it was too much of physical science, abstract of a thing. So I want to suggest that he may need to still give us a simple, analogy of what the study is all about. That's one. Then for the other presenter on SARS-CoV-2,
Can we have you in front, please?
Shegun. So I think the type of study, under the methodology needs to be indicated. Maybe when you are writing the entire manuscript, you need to tell us the type of study that you have carried out. Tell us how the data were collected. Did you use any questionnaire? How did you go about it? Was it pre-tested and all that? So let all that be included in the study, and that can make it, a better one. Thank you.
Thank you. Number 3. Number 3. Please, sir. The 6th presenter, what's his name? Sulaiman Awal Akinwumi, please come.
Okay, thank you very much. I want to make some comments regarding the molecular docking, the computer-aided drug design approach by that individual. I have some shortfalls regarding your presentation, especially your methodology. You didn't mention the software you use for molecular docking. I think from your pictures or your images, I see you used Discovery Studio for just an interaction. You cannot get interaction without using an appropriate method for your molecular docking. And secondly, I am not sure if you validated your molecular docking approach. I can't mention, there are so many names here. I don't know the exact person. Ibrahim, Olaide, Adedotun, Ms. Baudin, I think represented by that young man there. Yes, the person knows what I'm saying. You didn't mention your validation method. How did you validate your method? Then secondly, over the years, even when I have reviewed so many job papers, anytime I see the principal rule of 5, immediately I reject that paper. I'm sorry to sound this way, because it's most of the compounds and the extract you get from some of these plants, most of them will pass the Limpinski rule. That is just a fact. But most of them will fail BBB. Most of them will not pass through the BBB. So using the Limpinski rule as a rule or as a criteria for screening potential drug is wrong. And secondly, you did not validate using molecular dynamics. If you just do only molecular docking, and you pick some amino acid at the active site and you do your molecular docking, sincerely, most of them will fail. So if you don't do molecular dynamics, it's not well validated. The same thing with the other lady, the other woman, I'm sorry. Yes, the same question. How did you validate?
All
You
right.
didn't mention how you validated your method.
Thank you very much. So please note number four. Yes.
My question is directed to Dr. Akinwumi, the guy that detected SARS. I have a problem with your method. The RT-PCR, I don't know if it was a one-step PCR or a two-step PCR, because in your method you didn't say anything about the cDNA synthesis. I don't know if that was not captured. And for the water sample, did you check the temperature of the water to know? Because I'm worried that this virus is there. What is the temperature of that water? That will guide us to understand what specifically, will be driving that virus, because I don't know.
Thank you, sir. Number 5. Number 5. Oh, did I? Okay, number 5. All right, I think you're fine. Yes, it's fine.
Thank you. I want Mr. Ibrahim to tell us, is it that after the computation analysis, are you advising that researchers should go to the laboratory? Because I would have suggested that after computation, and you really want to validate, like the way some of my own study, when I do such simulations, and then I want to validate, I will now do maybe 20-30% laboratory to justify what I've analyzed, so that I can have a basis for the novelty I'm trying to present. And then to the man who presented mathematical model, I want to know what is the empirical application of this model. Is it trying to derive a new theory, or is it that I just want to know?
Okay, thank you very much. My question also goes to Dr. Akinwumi, that work on detection of SARS-CoV-2 RNA in wastewater samples. I just want to ask, because you mentioned that you took samples from, I think, sewage wastewater and also environmental waste. So I don't know what kind of environmental waste are you talking about, really? You didn't tell us what kind of sample when you talk about environmental waste. Also, considering the low positive samples that were recorded, considering your methodologies, you said it aligns with the case prevalence that was recorded in the country at that time, that the prevalence of COVID was already going down. I just want to ask that, don't you think when you talk about environmental waste, there could be some other reservoirs of this SARS-CoV that you did not check for? For example, it's been believed that it's possible that domestic animals could harbor this SARS-CoV. There could be SARS-CoV in domestic animals, which many researchers have not really checked in our country. So it's possible that even when there are low cases being reported in humans, some of our domestic animals that we have around us could still be harboring some of these viruses. Also, do you consider, like somebody asked that, did you check the temperature of that water? Do you think, I'm just asking, probably there could be some environmental parameters that could also be masking the detection of this SARS-CoV in the environment? Thank you.
So, Dr. Rahila, my question is, what are the specific gaps you identified and why you are recommending policy? You didn't mention that. What are those gaps? Number 2, my second question to Dr. Isheolu Akinwumi is, you didn't tell us, you made reference to treated and untreated water. Which are the treated, which are the untreated, and how many are they? Just in addition to other, that's why I'm not repeating some of them. Presenter number 3, Adedotun Olawale. How safe is your candidate bioactive compound? And then how long do you envisage it will take to translate from your candidate bioactive compound to clinical use? Number 4 presentation, Dr. Bezdin. The phytochemicals you recommended, are they targeted towards all the variants? Are they targeted towards all the variants of COVID, SARS-CoV-2? To the field presenter on literature review, in your presentation you told us that it's biased towards Scopus index. You mentioned that. So why didn't you consider other search engines in your studies?
Okay. Can I go?
Based on what you have just said, what direction you want them to, trajectory you want them to go? And to the last presenter, just like others, what is the application of your mathematical model? Thank you. So just in that order. Sit down, please. Just pass the mic once we're done.
Thank you very much for that interesting question.
Apologies, please. Let me quickly just take, somebody sent question, so let me just take that to presenter 2 on the environment. Is there any plan to look at the presence of SARS-CoV-2 on surface runoff water? And then, in my opinion, environmental waste should have a high percentage of SARS-CoV-2 in studies due to the disposal of millions of face or nose masks alongside other waste material. To my surprise, your research results showed a very small percentage of SARS-CoV-2 in the environment. Why? So just add that. Thank you. Sorry for interjecting.
Once more, I appreciate the question that came up. It's very interesting. And this is the right place to answer such questions because such environment is where we rub our minds and bring up